All right, so we're going to be talking about the law of cosines part 2. And so we've gone over an example where we knew two sides and the included angle. And so now we're going to go over the example of what happens if we just know all the sides and we don't know any angles. Can we still solve the triangle? All right, so for this portion of the lesson, we do need to have a calculator available. Now, if you have your phone on you, you can pull up the calculator portion of your phone by turning it, allow it to rotate. But if you turn your vertical calculator sideways, most of the time that turns into a scientific calculator, or you can just have a scientific calculator like mine handy, okay? So what I want you to do is in your calculator, find the sine of 150 degrees and find the sine of 30 degrees. And if you don't have your calculator yet, just pause the video and do that first before you hit it again. And so you should see that, the sine of 150 should have given you 0.5, and the sine of 30 degrees should have also given you 0.5, all right? So now what we want to do is the reverse. We want to take the inverse sine of that 0.5. So take a moment in your calculator to find the inverse sine of 0.5. And you'll notice, got a little ahead of myself, you only get 30 degrees. Your calculator isn't going to tell you the 150 degrees, only the 30 degrees, because a calculator needs to have what's called a function, that for every x there is exactly one y. So for the value at 0.5, my inverse sine can't give me two possibilities. It can only give me one. And we'll learn later why it's 30 degrees. But for now, just understand inverse sine is never going to give me an obtuse angle. Now, if we try cosine, so if you do cosine of 120 in your calculator and cosine of 60 in your calculator, write down what you get. So hopefully you see that cosine of 120 is 0.5. Let me say that again, negative 0.5. And cosine of 60 is positive 0.5. So now we want to do the inverse cosine of each of those values. So this inverse cosine of negative 0.5, figure that out. And then the inverse cosine of positive 0.5. Take a moment to figure that out. Pause the video if you need to. And so you'll notice that with the, I'm getting ahead of myself, with the inverse cosine of the negative, we did get that obtuse value of 120. And with this positive value, we did get that angle measure of 60 degrees. So cosine does allow for you to find obtuse angle measures, but sine does not. So since the sine of theta and the sine of 180 minus theta have the same value, meaning whether you're in the first quadrant or the second quadrant, the inverse sine is never going to give you that obtuse answer. It's just going to give you the first quadrant answer. And so if there's a choice, you should find the largest angle first using the law of cosines, or save it for last when you subtract. All right, so if we take a look at this triangle here, you'll notice they gave us an A value of 10, a B value of 4, and a C value of 8. So notice I know the length of all the sides, but I don't know the measure of any of the angles. So I call this a side, side, side situation, that we know the measures of all the sides, but we don't know the measures of the angles. So notice law of cosines is going to come into play either for side, 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 or side, angle, side. Okay? So in this case, we want to decide, do I want to start with my smallest angle and work my way up? Or do I want to go ahead and work with my largest angle and work my way down? And it doesn't matter which one you do, as long as when you use the law of sines, you're never looking for the biggest angle. So I don't want to mess up and possibly have A be obtuse and possibly try to find A in the law of sines. So I'm going to go ahead and find A first, because I know that cosine could give me that possibly obtuse angle. It doesn't mean it has to be obtuse. I'm just saying possibly. So by picking that, I'm going to use the equation a squared is equal to b squared plus c squared. So that's the Pythagorean theorem part. But we need to make an adjustment because we don't necessarily have a right triangle. So that's going to be minus 2bc cosine of a. So again, these two repeat here, and then this little a goes with this cosine of a. So let's substitute everything we know. So we've got 10 squared is equal to, and we get 4 squared plus 8 squared minus 2 times 4 times 8 times the cosine of a. Now, this one is not as easy to figure out as the previous one. So one of the big problems that I see people make is they want to combine all these numbers right here. But think about this. If I have 5 plus 4x, I cannot call that 9x because I have to multiply the 4 times x before I can add the 5. So the way that we can solve that problem is to always block this off and say, I can't combine these because I have to multiply before I can add or subtract. And so we end up with 10 squared is 100, 4 squared is 16, 8 squared is 64, minus, and then I get 2 times 4 is 8, times 8 is 64, cosine of a. And again, I'm keeping that in the brackets because I don't want to mix these up. So I'm just going to go ahead and subtract 16 from both sides and subtract 64 from both sides. So these cancel. And so if I do 100 minus 16 minus 64, that gives me positive 20 is equal to negative 64 cosine of a. So then if we divide both sides by negative 64, we get cosine of a is equal to negative 20 over 64. And so then remember, we can't divide by cosine because that would be like dividing by addition. It's a function, but I can take the inverse cosine of both sides. So that's telling me that the measure of angle A is equal to the inverse cosine of negative 20 over 64. So to be clear, that negative is really important, and if you don't use that negative, you're going to get the wrong answer. So we're going to do inverse cosine of negative 20 over 64. So you can use the fraction button or the divided by button. And that gives me an A value of 108.2, so 108 degrees. So it's lucky we didn't try to use this with the law of sines because it would not have given us the correct answer. So I've already got all 3 sets of sides. Now I have one of my angles. And again, this is one of those situations where we will need to use that rounded answer to be able to move forward. So we're going to use the law of sines and say that I have the sine of 108 over little a, which is 10, and that's equal to the sine of b over little b, which is 4, and that's equal to the sine of c over little c, which is 8. And it doesn't matter which one of these angles I find because I've already found my obtuse angle. I can't have another obtuse angle in the triangle. It wouldn't make a triangle. So I'm just going to go ahead and pick these 2 and solve for big B. So when I cross multiply, or I can just multiply through by 4. So I'm going to multiply this side by 4 and this side by 4. I get the sine of B is equal to, and then we get 4 sine of 108 all over 10. And then to get the sine of B away, we take the inverse sine of both sides. So these cancel, and I get that big B is equal to, and so we're going to do the inverse sine of 4 times the sine of 108, that's not correct, divided by 10 equals, and we should get B to be 22.4 degrees or 22 degrees, depending on what they ask for. They didn't specify, so I'm just going to do the ones place. Okay. And now I don't need to use the law of sines to continue. Oops. Because now that I have 2 angle measures, I just need the third one. I can say, well, 108 plus 22 plus C gives me 180. And so then on my calculator, if I do 180 minus 108 minus 22, I get that big C is equal to 50 degrees. And then one little double check, remember, the smallest side has to be opposite the smallest angle, the middle side has to be opposite the middle-sized angle, and the larger side has to be opposite the largest angle. And again, you're not looking at the picture, you're looking at the actual numbers. So by looking at those numbers, I think I have it all. And so since I now have all three measures of the sides and the measures of all three angles, I have solved that triangle.